Okay, this is a symbol for the real numbers.
Okay.
Alright. So we have whole numbers. Whole numbers, actually we'll start with natural numbers. Natural numbers are 1, 2, 3, on to infinity. Nothing in between. Not 1.1, not 1 1/2, just those numbers. Those are the natural numbers. Whole numbers include the naturals and zero. Okay? All right. Integers. Integers are the whole numbers and their negatives. Switching around, but
What was that just read to say?
That's 1, 2, 3.
1, 2, 3.
There's a right back. Wait, what is the I?
Come sit over here.
I'm in.
Is that a I?
She'll be moving back in a minute.
Is that a I?
Oh, really?
It's an R with an extra step.
Okay.
It's a symbol for real numbers.
Okay.
Okay, so if you have a whole number, then you also have an integer. That's what that means. But if you have an integer, it doesn't necessarily mean you have a whole number. Because an integer can be negative, and a whole number can't be negative. Okay?
Yeah.
Alright. If you have an integer, that means you have a natural number. But if you have an integer, a natural number, if you have an integer that's negative, that doesn't mean you have a natural number. Right? Because natural numbers are not negative. Alright, so now the next one is rational. And rational numbers are integers and everything in between. Such as 1/2, negative 0.5, 17 and 8/9. Everybody following?
Yeah.
Okay. So the number 2 is also a whole number.
Yeah.
And if it's a whole number, it's also an integer.
Mm-hmm.
And if it's an integer, it's also irrational. So the number 2 would be all of these things. But 1/2 is not an integer. 1/2 is not a whole number. 1/2 is not a natural number. 1/2 is only a rational number. Yes?
Like how the naturals in the whole and the integers is in the rational, is the rational and the natural?
I have no idea what you said.
The natural is in the whole.
Yes.
The whole is in the integers.
Yeah.
The integers is in the rational. Is the rational in the natural?
Right.
Is it?
Yes, I just said that.
I'm just confused here. Look, how is all 4 going down and,
Yes. All of these are rationals.
oh, so rational goes.
So if, don't go backwards. If you have a natural number, you have all of these. Because natural numbers are in all of these.
Natural numbers are whole numbers, right?
Natural numbers are whole numbers.
Okay.
The only difference between whole numbers and natural numbers is whole number includes 0. 0 is not a natural number.
I'm still lost, so like if you would draw arrows for it, like natural, would draw an arrow to whole would draw an arrow to
Okay.
integers, and
Natural.
go rational.
Goes to whole,
Yeah.
whole goes to integers, integers go to rational. But
Does
you
it
can't
start back over?
go backwards.
Okay, it's not going backwards. Can we go back up?
No.
Oh, okay.
But there are rational numbers that are all of these things because of what you just said. But there are also rational numbers that aren't any of these things. For instance, a rational number can be written as a fraction, a over b. The number 2, this is the definition of a rational number, that it can be written as a fraction. The number 2 can be written as a fraction, can it?
Yeah.
Right. Can 0 be written as a fraction?
No.
Yes.
Yeah.
0 over anything is 0.
I'm stupid.
Integers, negatives. Can't negative 2 be written as a fraction?
Yes.
Okay, so all of these things can be written as a fraction. But 1/2 is not an integer.
Nope.
Because it's between all of these numbers, correct?
Yep.
All right. So it just takes a little bit of time going through this. And the last one, irrational. Has 2 requirements. It does not end or repeat as a decimal. Does not end or repeat as a decimal. For instance, the square root of 2. On your, those of you who have your calculators, put the square root of 2 into your calculator, and it goes all the way across the screen, doesn't it?
Yes.
Now, most calculators round the last number. Round up or down to that last number. So you're not sure if that last number is the correct number or not. But if it goes across your screen and it's not a repeating number, then it would be irrational.
It would be.
So everybody put 1 divided by 3, 1/3. 1 divided by 3 in your calculator.
0.3 repeating. 0.3 repeating.
0.3 repeating. It does not end and it does not repeat. So since 1/3 repeats,
It's not an irrational number.
it's rational.
Wait,
Put
if it does repeat, it's irrational. If it doesn't, it's irrational.
right. 2/3. Put 2/3 in. What do you get?
Oh.
0.6.
0.6, but then there's a 7 at the end, right?
No.
Because your calculator rounded the last position. So that one repeats. So that one is rational as well. So 1/3, 2/3, those are rational numbers. So that's what you got to look for when you're doing this assignment. Your job today is to go through and evaluate the problems they give you, and also if they ask you to label your answers by these categories, you need to. And that means this. If I said the number, let's just do 1, and then I'll give you your assignment. The square root of 49 over just the number 2, what does that equal? What's the square root of 49?
7.
So this is 7 over 2, which is 3 1/2.
Yeah.
Is that a natural number?
No.
So don't write natural down.
Okay.
Is it a whole number?
No.
Don't write whole down. Is it an integer?
Yeah.
No.
Is it rational?
Yeah.
That's because it's written as a fraction.
It's not.
So, and as a decimal, what is 3 1/2?
3.5.
Which means it ended, right? It didn't repeat and it didn't keep going. That's why it's rational.
Wait. Oh.
Wait, so if it's irrational, it doesn't ever end.
Right, and it
Okay.
never repeats.
All right, I understand now.
But you are to give me all the categories of your answer. So if you did a problem like this, example 2, I'll go ahead and do this one, then we'll be done. Negative the square root of 16 over 4. What's the square root of 16?
4.
So this is going to be negative 4 over positive 4, which is
Negative 4? No, negative 1.
negative 1. Now, Is it a natural number?
No.
Is it a whole number?
No.
Is it an integer?
Yes.
Therefore, it is also
Irrational.
a rational.
It is.
So basically, if your answer ends up being a whole number, you better say it's whole, integer, and rational.
Oh.
If it's an integer, you better say it's an integer and it's rational. If it's irrational, that's the only possibility. Okay?
Okay, so like.
It goes down, it doesn't go back up, which is what Parker was saying.
So we do the whole problem and then write down whatever it is.
Yeah.
There could be more than one.
Yes.
Okay.
Like there's 2 here.
Oh. So if
So
it's.
you find the first category that it's in, and then go down from there. Your assignment.